we are going to look at Coulombs law. How does Coulombs law state? Coulombs law deals with the forces between two charged objects, and we're going to say force is equals to charge 1 times charge 2 over 4 pi epsilon r squared. So if you have two charged objects whose centers are separated by a distance r, and then you want to work out the force of attraction. So let's say this is a positive charge and this is a positive charge. These two charges are going to repel each other. If you have a negative charge here, they are going to attract each other. The magnitude of the charge that is going, the magnitude of the force that they are going to experience is given by Coulombs law. And how does Coulombs law state? We're going to say it states that force between charged objects is proportional to the product of the charges and inversely proportional to the square of distance, to the square of their separation. Yeah, so that is exactly what we are going to state when they tell you to state Coulombs law. And the formula for the force experienced by two charged objects is going to be given by F is equals charge 1 times charge 2 over 4 pi epsilon naught r squared, whereby epsilon naught is permittivity of free space, which is 8.85 times 10 raised power negative 7 farad per meter. Yeah, so this is a constant that is which is provided at the beginning of your exam, the first page. It's given there, so it's not something that you really worry about. All you need to cram. No. Yeah, so that's it. Now, we are given a scenario whereby there are two charged oil drops. Two charged oil drops. And these oil drops, they are separated by a distance. Two identical oil drops, they are separated by a distance. Let me check the distance here. Is 3.8 times 10 raised power negative 6 meters. That's the distance of separation. And then since we are told they are identical, it means they are going to have the same amount of charge. So we are told that they have equal charges. Yeah, so this is a charge Q, so meaning we can say they are positively charged, can say they are negatively charged, so they have identical charge. Yeah, so which means that we can be able to get the amount of charge by Coulombs law. To do that, we are first given the forces, the exact force on each other, and the force is given by the force given in this question was 6.3 times 10 raised power negative 19 newtons, and So it can be positive or negative, but we are dealing with the magnitude of the force is given here. So we can be able to apply this formula. So we're going to say the force is 6.63 10 negative 17 is equals to Q squared, because Q times Q will give us Q squared. The magnitude was the same. Then 4 pi epsilon naught. And this epsilon is 8.85 times 10 raised to the power negative 12. Then distance of separation, we multiply it there, which is going to be times 3.8 times 10 raised to the power negative 6. So if we work it out and we find the square root here, because if we multiply this part on the other side and find the square root, we are going to have the value of Q equivalent to 3.2 times 10 raised to the power negative 19 coulombs as the charge for this particular question. Another question that is also given here is whereby we are told that one of the oil drop now is placed between two horizontal metal plates. One of the oil drop is placed between two horizontal metal plates. This metal plate is at a positive potential of 1200 volts, and this other one is at a zero potential. This one is at a zero potential. So if it's at a zero potential, it means there is a potential difference between the two plates. So what does that mean? We are going to have uniform electric fields between the two plates. So one of the questions that was asked in this particular paper is for you to draw the pattern of the electric fields between the plates. So we shall be able to draw it like this. This is the pattern, and then we are told now there is a stationary oil drop. One of the oil drop is placed between the two plates. The potential difference is applied between the plate and the top plate. There is a potential difference applied on the top plate at a higher potential. The oil drop stationary in equilibrium, so it's at equilibrium at this particular point. And then you are asked to state the sign of the charge. So if it was a positive charge, it will be repelled by this plate and it will accelerate toward the to the plate of a lower potential. So which means that this has to be a negative charge. This is a negative charge. And I'm saying it's a negative charge because it will be attracted by the positive plate and the weight will be acting downward. So the force of attraction towards the positive plate and the weight of this oil drop are balanced, and that is why we can be able to see it being stationary between the two plates. The next question is to find determine the mass of the oil drop at the mass of this oil drop. So something that we need to appreciate here is that the electric force is equals to the weight of the electric force experienced by the oil drop is equal to the weight of the oil drop. And to get the electric force, remember, electric force is charge times the electric field, and the weight is mass times gravity. So which means that our mass is going to be the charge of the oil drop times the electric field between the two plates divided by the gravitational field strength. So that goes without saying that we can be able to work out E, and our electric field between the plates is going to be the potential difference over the distance of separation, and the distance of separation of these two plates was given as 5.2 centimeters. This is 5.2 centimeters. So meaning we can be able to work out the electric field between the two plates, which means that we can be able to go ahead and say now, if we substitute E with VD over D here, our equation is going to be mass is equals to VQ, and I'm using the small charge Q, meaning Q is the charge of this oil drop, and over dg, where d is the distance of separation and g is the gravitational field strength. Now if you apply this by substituting, we are going to have 1200 times 3.2 times 10 raised to power negative 19, and this is the charge of this oil drop, which had been obtained from the previous part of the equation. Distance is 5.2 times 10 raised to power negative 2 times 9.81, and if you work out this, you are going to get your answer 7.5 times 10 raised to power negative 16 kilograms. And now this becomes the answer in this particular case. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. So, and I usually add the tutorials notes, the PDF of our notes in our Patreon page, so you can be able to join there. So see you in the next tutorial. See you in the next video.